Data masking is defined within the structure of a table. This is a masked with syntax along with the definition of a column in a table. Even though it's not specifically security, it does help to display data in an untyped secure way. The function keyword provides the logic that changes the display of the data in the particular column. You can see the mask statement used in the create table to your right. There was one with default for phone number, email for email address, a custom one for credit card number, and the default for birth date. The display is changed for the particular users viewing the data. Nothing is changed with the storage physically of the data on disk in the database. Those with the correct permissions will be able to view the masked data as stored within the database. The insert, update, and delete of these masked columns is not affected by the definition. Data will always be present. The permissions are controlled by login, so you need to configure the logins to either see unmasked data or just mask the data. Data security is always one of the most important points which cannot be ignored in this particular day and age. Nowadays, if you're working with any specific domain like banking or healthcare, then there's a lot of compliance rules which must be followed. Data masking is just one of the best ways now to help you secure your sensitive data by applying a data mask. It is not like encryption where the data is encrypted. It just helps mask it from display to particular users. In my opinion, this is one of the best new features of SQL Server 2016, which I really like. Data security is always one of the most important points which cannot be ignored. Nowadays, no matter where you are, you have compliance rules that must do something with the display of data or the storage of data. So why data masking? Well, this new feature of SQL Server 2016 helps protect against unauthorized viewing of companies' sensitive data. The application will return special formatted strings in place of this sensitive information. It uses built-in functions or custom strings which help the application display, but privileged users will still be able to see the unmasked data. The compliance side of a regulatory department will be well pleased. There is an overwhelming demand for applications to be more private and privacy enabled. This need has to be standardized from your enterprise regulating people. On-the-fly masking of the underlying data is seamless in SQL Server 2016. It though protects the data stored on disk at your database and file level. Transparent to the application, and this makes it simple for this new feature to be implemented in production databases in a breezy type fashion without much downtime. Data masking is one of the best ways to help you secure your sensitive data with dynamic masking of kind of like encryption display. This is one of the best features that are implemented in SQL Server 2016 to help you with security. In implementing it, there's a default function which fully masks the data and displays kind of like 4 little X's. There's one for credit card numbers which mask everything except the last 4 digits of the credit card. You can kind of see a pattern here. Social security numbers will be XXX-XSX-1234. So you need a custom one if you still want to show the last 4 digits of the social security number. Randomize is just a random set of display items based on boundaries you define in the function of the column. There's even one for custom text where the first and last characters are displayed, but you create some custom filler for the middle of the masked data. And lastly, and probably more in the future, is one for email option. With the basic email, you'll get the first letter of the first part of the email address, xxx@xxx.com. The .com will always be there as the domain, no matter if the actual email address is .net, .org, or some other variation. With the help of dynamic data masking, you are just applying this mask to your sensitive data. For example, if your system is storing Social Security number data, then it should be visible to privileged users, or we can say authorized users only. Dynamic data masking has the following features. 1. It masks the sensitive data. 2. There's no impact on functions or store procedures that use the masked data, or any other SQL statement after applying this mask. Of course, it is super easy, as you saw in the create table. You can also do an alter table, alter column to provide the function for data masking. You can allow any database user or role to see unmasked data by just simply a grant or revoke type statement. Same thing you use with any other security or permission. Data is not physically changed. It is on the fly, and it affects the data query results. It is just a T-SQL statement with basic syntax. Now that we understand it a little more, it'd be better if we saw an example. Here's a demonstration of using data masking. We're going to launch SQL Server Management Studio. We're going to connect to our SQL Server 2016 instance to do this demonstration. Next, we're going to drill down into the AdventureWorks database and create a new query. We're going to go to the File menu choice and open up a solution that has a script for us. In this script, we're going to open up the data masking. I'm going to show you, after we connect to the AdventureWorks 16 database, that the employee table here has unencrypted data or unmasked data in this national ID column. I'm going to go ahead and alter that table, alter the column, and add mask with function default. Now, logged in as this current user, if I go select that data again, I don't see any changes there. But if I copy this and go connect to a new, let's create a new query window. I'm going to change my connection to a SQL login called data mask. Make sure I get the right password. Once I'm connected, I can go to that same database, run that same select, and you'll notice that default data mask has been applied. So if I run it as me, which has full privileges, I see the data, but if I run it as the data mask guy, I don't see the data. Now let's do one more. And to do this one, I'm going to drop a table, and then I'm going to select some employees' email addresses into a new table, and look at that new table. There's the addresses, a0@adventureworks.com. I'm going to alter that table, alter the column, make sure it's a varchar value, and also mask it with the email. And again, if I go look at this, I don't see the masked data. But if I go grant the select on those particular tables for that data mask new login, it's already assigned to the database. Now, if I go back into that same query window where the data mask is logged in, and I can see that just by going to connect, can't change connections, and say data mask, just to make sure I'm not doing anything incorrect with y'all. And I go look at those particular tables, I now see the email address is masked with just the first character. If I go farther enough down, you'll see other variations of it. There's the J's, and I think we saw some G's and E's. And then you also see the national ID number. So you can apply this email function, a custom one, or a default data mask on columns. And then by granting the particular permissions for those particular tables to a separate user, then that user will be masked based on what you defined. So ending the security part of this Exploring SQL Server 2016 with any new feature or any new version of release of SQL Server, there's going to be new permissions. The first one is alter security policy, which we looked at earlier for adding security policies to table value functions. And this permission is available as part of this implementation of row level security. Alter any mask and unmask we saw in the previous slides, and it's available as the implementation of dynamic data masking. Then we have a series for the always encrypted, an alter any column for encryption key, a view any column encryption key, an alter any column master key definition, as well as view any column master key definition. So if you notice, there's an alter any and a view any. So there's really only two basic permissions with always encrypted. Either you can alter information or you can just view it, or you can't do anything without any permissions. There's also an alter any external data source and an alter any external file format. These permissions are visible in 2016, but they only apply to the analytics platform system, which is involved with the SQL data warehousing in the cloud. Execute any external script permission is available for really just the R scripts, but since you notice the internal scripting is not specifically for R, that means other versions of scripting language are available. There was a demonstration not too recently of Python in SQL Server vNext, or what's been renamed to SQL Server 2017. Also, there's finally one alter any database scope configuration. This permission is available for users that actually change the scope configuration of a particular database. The other security options are transparent data encryption. Even though this has been in previous versions of SQL Server, it has been enhanced with the support of the Intel ASE-NI hardware acceleration for encryption. This new hardware level has been added to reduce the CPU overhead of turning on transparent data encryption. So in previous versions, there's been a spike in CPU usage. Intel has used a hardware acceleration, and now this is supported in 2016. There's many people using transparent data encryption as well as SAN level encryption. Also, ASE encryption for endpoints has been added. The default encryption for endpoint is changed from RC4 to ASE. You need to know that if you've used encryption in the past. The new type of encryption level is the database level. A credential can now be created at the database level in addition to the server level credential that was previously available. For more information about this, you want to look for that Create Database Scope credential inside of Online Help.